In this lecture, we'll be studying about message passing systems. In the previous lecture, we have studied about another kind of interprocess communication, which was a shared memory systems, in which if two processes wants to communicate, they do so by sharing a portion of memory, which resides in the address space of one of the processes. And when they want to communicate, they write to that shared memory, or they read from that shared memory. Now we'll be discussing the next kind of interprocess communication, which is the message passing systems. So we have seen a brief introduction about this message passing system when we discussed the lecture of interprocess communication. But in this lecture, we'll be studying in more detail about this message passing system and how this message passing systems actually work. So message passing provides a mechanism to allow processes to communicate and to synchronize their actions without sharing the same address base, and is particularly useful in a distributed environment where the communicating processes may reside on different computers connected by a network. So as I already told you, when we discuss about shared memory system, we saw that the communication took place by sharing a region of memory between the two processes. But in this message passing system, we are not going to share any region of memory, but we are going to have a communication between two or more processes without sharing any address space. And why is this useful? This is useful in a distributed environment. So for example, let's say that the processes that wants to communicate, they lie within the same system. Suppose two processes within the same system wants to communicate, then it is easy for them to create a shared region of memory, which is a shared memory, and they can communicate using that shared region of memory. So as we already studied, the shared memory, it lies in the address space of one of the processes. And both the processes that wants to communicate needs to be able to access that region of shared memory. But think of a scenario in which you have a distributed environment or a communication process that resides on computers connected by a network. So for this, let us take the example of internet chat. So let's say that you are chatting with your friend over the internet. So you are sending message from your system, and your friend is receiving the message in his system that is located somewhere else. So even in this place, the two processes needs to communicate. Your process from your system and the process in your friend's system also needs to communicate, but they are not residing in the same system, but they are residing in different systems, connected through a network. So in this scenario, it is difficult to create a region of shared memory that can be accessed by these two processes. So in this kind of scenario, message passing system can be used where the communicating processes will communicate via some kind of messages, which will be sent from one process to another process. So in this way, they don't need to have original shared memory, but they can send messages to another process, and also it can receive messages from other processes. So that is how message passing systems work. So we'll go into the details of message passing systems, and we will see what are his features and how does this message passing system actually work. So the message passing facility provides at least two operations, which are send message and receive message. So these are the two operations provided by a message passing facility. The first one is send message. So from the name itself, it is understood that send message is the operation that allows the process to send the message to the other process to which it wants to communicate. And then we have the receive message operation. So the receive message operation is the operation which allows the process, which is the recipient of the message, to receive the message from the other process that is sending the message. So these are the two operations that we have in a message passing facility. And then message sent by a process can be of either fixed or variable length. So when the message is being sent from one process to another process, the length of the message or the size of the message can be either of fixed size or variable size. So fixed size means the message will have a particular size that will be fixed and it cannot exceed that size. And variable size means the size of the message can vary. It can be big or it can be small. So let us see what are the features of this fixed size messages and variable size messages, and how easy is it to implement this? Two kind of message sizes. So in fixed size, the system-level implementation is straightforward, but makes the task of programming more difficult. Now, why do we say this? In fixed size, it says that the system-level implementation is straightforward. It says so because if you are going to implement a fixed size system, the system-level implementation is easy. Or it is not very difficult. Because when you are designing your system, you have to design your system in such a way that the length of the messages that will be sent by processes will be of fixed size. So in that way, the implementation is straightforward. So the system-level implementation, that means the way in which the system is implemented, is straightforward and easy because you just have to maintain a fixed size. But it makes a task of programming more difficult. Now the task of programming becomes more difficult. Now what is a task of programming? So when you are programming, you may have to control the way in which the messages are sent from one process to another. But you have to always keep in mind that the size of the message should be fixed. You cannot vary your size of the message. So sometimes when you are programming, you may want to have messages of larger sizes, but it is not possible because we are only allowed to have messages of fixed size. So that is why it says the task of programming becomes more difficult in this fixed size matter. Now coming to variable size, it requires some more complex system-level implementation, but the programming task becomes simpler. So in case of variable size messages, it requires some more complex system-level implementation, which means that when you are designing the system, it may be a little more complex, or it may be a little more difficult because you have to allow the messages to be of any size, or variable size. The size should be allowed to vary. So when you are designing something of that form, the messages should be allowed to take any size. They may be bigger size or smaller size, and it must be versatile in that way. So the system-level implementation becomes more complex, but the programming task becomes simpler. But in this case, the programming task becomes simpler because when you are programming, it is easy for you because you are not having a restriction on the size of the messages. So if you want to program something controlling the communication between two processes, then it is easy because you don't have to worry about the size of the message that has to be sent. It can be of any size, so the programming task becomes simpler. So those are the two kinds of message sizes that we have, fixed and variable size. Now if process P and Q wants to communicate, they must send messages to and receive messages from each other. So let's say that we have two processes, P and Q, that want to communicate. So if they want to communicate, then they must send messages to and receive messages from each other. P and Q must be able to send messages to each other, and P and Q also must be able to receive messages each other. Now, how can we facilitate this? So in order to make this happen, a communication link must exist between them. So there must be a communication link between the process P and process Q so that they can have communication with each other. So, unlike shared memory, in which the communication took place by writing into a region of shared memory and reading from the region of shared memory. So in case of message passing system, we must have a communication link between the two processes that wants to communicate. So how do we implement this communication link? So this link can be implemented in a variety of ways. There are several methods for logically implementing a link and a send and receive operations, like the ones given below. So here we are concerned about the ways for logically implementing a link. We are not concerned about how to physically implement the link. So the way in which the link can be physically implemented will be discussed in another chapter later on. But we are concerned about how can we logically implement this link between the two processes that wants to communicate and send the messages to each other. So it says here that we have several methods for implementing this link and send and receive operations. We have already discussed the send and receive operations. So for implementing this, there are several methods, like the ones given below, like direct or indirect communication, synchronous or asynchronous communication, automatic or explicit buffering. And there are several issues related with features like naming, synchronization, and buffering. So these are the methods we have in which we can logically implement a link so that the processes can communicate to each other, and there are several issues associated with these features which are given here, like naming, synchronization, and buffering. So this part, which is the methods for logically implementing a link, and the issues associated with these features, like naming, synchronization, and buffering, will be discussed in the second part of this lecture. So I hope this first part of message passing systems are clear to you. Thank you for watching, and see you in the next one.